Yeah,
Aditya, you can go ahead.
sure. Hello everyone. My name is Aditya Patil, and we are part of Team 11. And along with me, I have Anitosh, Rajesh, Girish, and Janvi in Team 11. Basically, our project title is Travel Itinerary Planner using Semantic Web. So, Rajesh, can you please move on the next slide? So, yeah. So currently, the problems we fetch are generic recommendations, limited access to location-specific information. So I can explain you this with an example. So, like for example, you have to go to Phoenix, and you just enter Phoenix into Google. Like you ask Google to generate an itinerary. So Google doesn't give you personalized itinerary for your preferences. It just give you suggestions. So you're not able to figure out, right? So to solve this problem, we came up with our application that is the itinerary planner. We call it Travel Path. So basically, what we can do is we just ask for some user preferences like location, a day, a number of days, a number of people, the mode of transportation, and based on their preferences, we are generating the itinerary, detailed itinerary. So Rajesh, next slide, please. Yeah. So this is basically the homepage of our application. As you can see, it mentions the title of our application, and below that you can see the Get Started button. So when you click on that Get Started button, you are asked your preferences like the days, location, and all that part. We have also provided the authentication to it. Yeah. So coming to the technologies and tools we have used. So for the ontology generation and querying part, we are using tools like Prodigy, Autodesk Define, and SparkQL. And for the geo-coordinate parts, we are using GeoSparkQL. For the backend part, we are using Python's Fast API, WebSocket IO, SparkQL Wrapper, and Geolocation API. Coming to the database part, we are using GraphDB and Google Firebase to store our data. And uh, the UI, which I showed you on the previous slide, for the front end part, we are using React.js. Along with that, for the CSS, like we have Tailwind CSS, then we have WebSocket client and Google Places here to display the real images from like fetch from Google. And for the deployment, we are using Hostinger, Vercel, and GitHub. So this was all about the technologies and tools we are using. So next slide. Yeah. So I think Rajesh will take over on this.
Yeah. So for the data sets that we are using, so our primary database, that is GNIS dataset that we are using, that's from US government, and it is providing geographic and information about places like lakes, for example, and along with that, we are using data sets from Institute of Museum and Library Services. Again, it's a public organization. It has information about the museums, aquariums, and zoos in the United States. Data set from Yelp, which has locations, user reviews, the categories of restaurant, etc. And for the transit part, we are currently using City of Phoenix's transit data, that is Valley Metro, and it provides data about the bus stops and the metro stations in Phoenix. Yeah. So coming to the ontologies, as I said, our uh, ITP, that is the ontology that we have developed, it's based on top of GNIS ontology. So as I said, it's built on top of GNIS ontology. That is the key element of that is the feature class. So which is essential for calculating the distances, geo distances, and the classes that we have defined, for example, places of interest, which includes stuff like museums, monuments, and some natural attractions like beaches, national parks, waterfalls, lakes, etc. Yeah. Coming to the object properties, we have some properties like located in. So this gives it links a place of interest to a particular city, which links a feature to a particular US state. So for example, Grand Canyon is linked to Arizona. And now coming to the data properties. So the important part, that's the longitude and latitude, which are used to develop our calculate the distance, geodistance, is being stored in these data properties, it's a double. And similarly for we have a feature name, and for the user we have profession, gender, age. So the main key part was to convert our data sets that were mostly in form of CSV into turtle format. So as you can see, I have opened the museums dataset, which was in CSV, and we have mapped it to a geometry. Yeah. So coming to one important key feature was storage of latitude and longitude. So GeoSparQL uses this uh, geometry data to calculate distance between two uh, places. So we were able to generate turtle files for all our data sets, and those turtle files are being fed to our GraphDB, which is acting as a central repository for our knowledge graph. So as visual representation of our ontology, as you can see, this is the feature and everything is a subclass of a feature. This is the class hierarchy for our train stations in 1 kilometer radius. So that was mostly about the ontology and the SparkQL templates.
The entire application is based on a layered architecture. So our application is divided into four crucial parts: front end, back end, knowledge layer, that is our data layer, and our ETL system. The back end is orchestrated using a UVCon application orchestrator. So we will come back to that later. So side by side, I will go through the code. This is so as this is a layered architecture, it also comprises some features of MVC. It has models, it has routes for route handling, it has schemas for dynamic query generation, it has service layer. So let's start with the architecture. I will go from bottom to up. So our ETL system, which mostly comprises of onto text refine, which is responsible to generate the turtle, the triplets. That triplets are then fed to the GraphDB. That GraphDB is hosted on a bare metal server, which is provided by Hostinger. The GraphDB comes with an SparkQL endpoint, which is connected by our backend layer. Backend layer has a component called a GeoSparkQL service layer. That is called SparkQL wrapper service. So you in the code you can see that that service is present here. The SparkQL service. The main task of this service is to connect with our knowledge graph. Coming further, the core of the backend service lies here, which is itinerary service. Itinerary service comprises of three main services, that is point of interest service, restaurant service, and transport service. So each service has a specific role. Point of service is used to generate queries, which takes help of query generation service to generate dynamic queries dynamically based on the user preferences. Again, the restaurant service uses the same query generation service, and the transport service uses the similar service to generate the queries. So you can see these services here. Here the service request for the query from the query engine and sends that query to the SparkQL service. And the fast SparkQL service will further communicate with our GraphDB layer to evaluate the query and bring the results back to the service layer. Once the service layer, that is our core service layer, itinerary service, receives the data, it forwards that data to the front end via socket communication. So that code you can find it here. Here we are setting up a socket host which connects to the front end. So we are sending the data in the chunks to the front end, as the entire itinerary generation takes time. Coming to the front end we have socket client and a user management service. So user management service communicates with our application database, which is primarily Firebase. So the Firebase maintains all the user interest and preferences data, and also the authentication details. Our front end is developed in React, uh, and it communicates with backend via socket. So here, as you can see, that we have established a connection with our backend. We are sending the user preferences data that we fetched from the Firebase, and after sending data to the backend, we are waiting for the backend to generate the itinerary item. And as soon as the itinerary item is brought to the front end, we display it on UI. So entire thing is an iterative process. So uh, I hand over to Janvi to give you the demo of application.
Our front-end application demo, we have deployed our front-end React application in Vercel, and we are using Firebase database to store the list of users, their preferences, and their interests. This is our landing page. We have implemented a user authentication process. When you click on sign in, you'll be able to sign in with Google. Here we have leveraged React libraries to integrate OAuth 2.0. And then when you're successfully signed in, our application will fetch the user information from Google API, and you'll be prompted to complete your profile. And when you click on save details, you'll be directed to the home page. And when you click on get started, you'll be directed to the travel preferences page, where you'll be able to input your location, your duration of stay, a number of people if you're a solo traveler or traveling with a couple of friends, and the mode of transport. And when you click on generate itinerary, it will take you to user preferences page, where you have categorized sections for food preferences and interests, which are really important and crucial for generation of a personal itinerary. And after selecting all your preferences, you'll be able to click on generate. Handing over to Girish.
Thank you, Janu. So now that we have got all the data from the front end, our application uses the WebSocket protocol to establish a seamless connection between the front end and the backend services. So the main advantage of using this protocol is the bidirectional communication between the front end and backend, so that we can exchange real-time data and the user gets the real-time inputs from the real-time inputs. So that so the backend, so as we have got all the data from the front end, the backend then dynamically processes the data and creates a dynamic query and then passes it to the GraphDB to load it or load the data. And once the data is processed, the system communicates the updates back to the front end. So by using this bidirectional architecture, we enable the seamless communication between the front end and back end, and which also allows the user to get the real-time updates. As you can see here, this entire itinerary has been tailored according to the user preferences, and we have also got the uh, time through which the user can travel between those. So thank you. So now